Hey guys, we're going to be jumping into chapter 9 here where we're going to look at quadratics, quadratic equation and quadratic graphs and all these different things. So a lot of vocab in section 1, so I apologize. Make sure you stretch your wrist. You'll want to pause and copy all of this down. A quadratic function is a function that can be written in the form of y equals a squared plus bx plus c, where a is not equal to 0. This is the standard form of a quadratic function. Some examples would be 3x squared, x squared plus 9, x squared minus 1 minus 2. Notice on these that there isn't a bx or a c. That's because they're 0. On this one, there's not a bx. That means b is 0. b times x, or 0 times x, makes it go away. This one has all of them. The simplest quadratic function is f of x equals x squared, or just y equals x squared. This is called the quadratic parent function, meaning just the most basic one that there is. More vocab. Quadratic graphs and their properties. Make sure you pause and copy this down as well as draw this picture. The graph of a quadratic function is a U-shaped curve called a parabola. Not parabola. It is parabola. An axis of symmetry is the vertical line that cuts the parabola in half. So on this one right here, it is the y-axis. A parabola can be folded on itself. It's perfectly symmetrical. The highest or lowest point of a parabola is called the vertex, sometimes called a minimum or a maximum. So the vertex lies on the axis of symmetry. Okay, the axis of symmetry goes through the vertex. It's the vertical line going through that particular spot. All right, so what did you do over, we're not at the spring break yet, so this is what you could do over spring break if you wanted to. My family gets Zoom memberships every year, and I'm not allowed to take the kids' grandpa, and here's why. My grandpa has the heart of a lion and a lifetime ban from the zoo. Oh, that's good. All right, so identifying a vertex says what are the coordinates of the vertex of each graph? Is a minimum or a maximum? This should be really, really simple. I'm looking for the point where it cuts it in half. So this is a ordered pair of 0, 3. And notice that if I start at this, are there any points that are lower or any points that are higher? Well, there are some that are lower, but are there any that are higher? No, because of that, we would say that this is a maximum. Take a look at this one over here. So here, I have the vertex right here, and I'll notice that there's nothing that goes below that. So first of all, we'll write our ordered pair, which is going to be 1, -1, and then that one is a minimum. All right, so this one's max, this one is a minimum. Let's keep going. All right, so graphing y equals ax squared. It says graph the function y equals 1/3 x squared. Okay, so when you are graphing a quadratic, I'm going to show you something kind of nice here. If I'm going to graph a quadratic, let's come up with an XY chart. There we go, XY. And I'm going to put in 0, just a couple points. 0, let's try a 3. I'm picking 3 so it gets rid of these stinking fractions. And then another multiple 3. How about 6? All right, so 0, 3, and 6. I plug in 0 for the x. Well, that's 0. 0 times 1/3 is 0. Plug in 3. 3 squared is 9. And then 1/3 of 9 is 3. Plug in 6. 6 squared is 36. And 1/3 of that is going to be 12. All right, so the nice thing about graphing a parabola is, notice I didn't put any negatives on here. That's because a parabola is symmetrical. So if I go and I start plotting these points, which let me change my color here so you can see it. If I start plotting my points, I'll put my first one here. And then I go to 3, 3, and put my next one here. And then my last one here is going to be at 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just kind of guesstimate where it's going to be. Whatever the other side is going to be symmetrical to that. So if this is my axis of symmetry and this is 3 away, that means this other side is also 3 away. So that if I were to put -3 in here, I would still get 3 as my solution. Or this one over here is going to be, let's see, roughly here if my graph were to extend all the way. And then that's the kind of graph that it's going to look like. So it goes like this. And that's my parabola. All right, now it asks this other question here, the domain and the range. Remember, domain is the x values, and the range are all the y values. So the domain for this one, well, it would continue going in both directions forever and ever for all x values. So we would say all real numbers. And the range, notice this has a minimum, so it's all the values that are greater than that. So the range is going to be y greater than or equal to 0. All of the y values that are above 0, because there aren't any down here. It's all up here. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, here is what I got as a chart. Remember, if this is 1 away, then this is 1 away. I ran out of room down here on the bottom, but notice that this is a narrow function, or a graph of that function. Domain and range. Domain for parabolas is always going to be all real numbers. Okay, if it's a quadratic, then it's going to include all x values. The range may be a little bit different on that. Let's keep going here. All right, so it says comparing widths of parabolas. What is the order from widest to narrowest of the graphs of the quadratic functions? The absolute value of the a value is going to determine how wide a parabola is going to be. Fractions are wider. And then integers are more narrow. And the way this works is the smaller the absolute value of this number, the wider it's going to be. The greater the absolute value of the a value, the more narrow it's going to be. So if I'm going from widest to narrowest, I'm going to start with 1/4 x squared. Then just my parent function, x squared. And then negative 4x squared. All right, so the widest is this. This is the narrowest. Again, it has to do with the absolute value of that a coefficient. All right, so how is the graph of y equals 2x squared plus 3 different from 2x squared? Well, let's look at the way that these are going to graph. For the sake of time, I'm not going to be drawing out a table. I encourage you to do that. But for this one right here, we'll do this first one in blue. So we'll say that, and then when x is 1, y is 2. When x is 2, that would be 4 times 2, so that makes it 8. And I'm running out of room, but we'll fill that in, and we could fill that in. And then our graph looks something like that. Now this one, notice for all of these values down here is going to be the same thing, just add 3. So that should trigger something in your mind. You should think, well, the shape then, when it's 0, instead of it being 0, it's going to be 3. Instead of it being 1, 2, it's going to be here. So that'll be 1, 5. And then this one will actually be off of the graph. So that will be somewhere up here. And this one would be somewhere up here. And this would be here. What you should notice about these two graphs is that they have the same shape. They have the same shape. Let me get my thing working. Same shape, but 2x squared plus 3 is shifted up 3 units. So they are the exact same shape, except this red one is just up 3 from where that is. And let's keep going. All right, using following object model. It says an acorn drops from a tree branch 20 feet above the ground. The function h equals negative 16t squared plus 20 gives the height h of the acorn in feet after t amount of seconds. What is the graph of this quadratic function? At about what time does it hit the ground? So if you think about dropping an acorn from a tree, it doesn't take long, even if it's 20 feet, it doesn't take long for it to get to the ground. So when I'm going to fill out my values here, I'm going to think a little bit and think, well, it probably takes a couple seconds for it to fall to the ground, if that. So I'm going to just put in some values, and we're going to test these values out. So here's my function. I'm going to put 0 in. Well, 0 squared is that times negative 16 plus 20 is still 0. 0.5, if I put that value in, I get 16 feet. And again, I'm moving kind of quickly. You need to calculate these, but I'm trying to save time. If I put in 1, it's going to be at 4 feet. And 1.5 is going to be negative 16 feet. Well, I can't have negative 16 feet, so I'm just going to stop there. I don't even need to mess with 2. Okay, so we got to figure out about what time does the acorn hit the ground? Well, it's happening in between here and here, and this number's closer to 0 than this, so what I would say would be just a little after 1 second. All right, so it's closer to 1 second than it is to 1.5 seconds because this is closer to 0. Let's see what this is going to look like if I were to graph it. Now, first of all, I don't have enough spaces here on my graph, so I'm going to change some stuff. I'm going to say this is the number of feet, okay, the feet in height, and then the amount of time that goes by, let's go up by this. All right, so at 0 time, it's at 20 feet. At half a second, it is at 16 feet. At 1 second, it is at 4 feet. And then I couldn't get to 1.5, but if I follow this trend down and I were going to graph it, I'm only going to be graphing in the first quadrant because I'm not going to have negative feet. All right, so this is what the graph of the acorn falling is going to look like. It starts at 20 feet. And then it falls down until it hits the ground. Where it crosses the x-axis would be where it hits the ground. So hopefully that makes sense. That's it for today. So hopefully you took good notes. I will see you all in class.